Let's very briefly review the unified geometry incidence postulates, definitions, and propositions that we did from our previous playlist, from playlist 1, from last week's notes. Postulate 1, the collection of all points in geometry forms a set called space. The definition, a non-empty set of points in space is known as a geometric figure. Postulate 2, lines and planes are geometric figures. We have definitions. We say that two geometric figures are equal if and only if they represent the same set of points. Number 2, if a point A is an element of a line and a plane, we say that the point is on the line and in the plane if the line and plane contain the point. We also say that the line goes through the point. Similarly, we say that a line lies in a plane if it is a subset of the plane. We say the set of points is collinear if and only if there exists at least one single line containing all of the points in the set. Non-collinear is the negation of collinear. We say the set of points is coplanar if and only if there exists a single plane containing all the points. And then non-coplanar is the negation of coplanar. There exist at least 4 non-collinear, non-coplanar points. Every plane contains at least 3 non-collinear points. Every line contains at least 2 points. Given any 2 distinct points, there exists exactly one line that contains both of them. We say that 2 points determine the line if and only if postulate 6 is true. Given any 2 distinct points, there exists exactly one line that contains both of them. We represent the unique line containing points A and B as A and B with a little line symbol over it with arrows on both ends. Given any 3 distinct non-collinear points, there exists exactly one plane containing them. Another definition is we say that the 3 non-collinear points determine a plane if and only if that postulate 7 is true. We represent the unique plane containing non-collinear points A and B and C as plane ABC. Postulate 8, if 2 points lie in a plane, then any line containing them lies in the plane. Postulate 9, if 2 distinct planes intersect, then their intersection is a line. And from those, we can prove a few propositions. Proposition 1, there exist at least 6 distinct lines and 4 distinct planes. We'll prove that in our next video. Proposition 2, if 2 distinct lines intersect, then they intersect in exactly one point. That actually depends only on postulate 6 only. Actually, a weakened version of postulate 6 implies that, proposition 2. Proposition 3, if a line intersects a plane not containing the line, then the intersection is exactly one point. Proposition 4, given a line and a point not on the line, there exists exactly one plane containing the given point in the line. A couple more definitions. 2 lines are parallel lines if and only if they are coplanar and non-intersecting. 2 lines are skew lines if and only if the union of the 2 lines is non-coplanar. Proposition 5, if 2 lines intersect, their union lies in exactly one plane, and skew lines do not intersect. So that's our list of postulates, propositions, and definitions that we have thus far. Notice that postulate 3 is an incidence, an existence postulate, that should say. Guaranteeing the existence of at least 4 distinct points, which are not all on the same line and which are not all in the same plane. Starting with this, we can use the other postulates in combination to determine that there must be at least 6 lines and 4 distinct planes. However, with these postulates only, there's no guarantee that there are any more points, lines, or planes in geometry. In fact, in homework set 1, you were asked to develop a model of a finite geometry that satisfies the postulates above and consists of exactly 4 points, 6 lines, and 3 planes. And we will provide a proof of proposition 1 and generate such a model in the next video.